My dear students, in the previous video, I have solved some problems in integral calculus using Bernoulli's formula. Now in this video, I am going to introduce Gama integral. Gama integral. A special type of integral is called Gama integral. Before introducing that Gama integral, you consider the integral In equal to integral 0 to infinity e power minus x into x power n dx. See, you have to evaluate this integral using integration by parts. What do you get? By evaluating this integral, I am going to define Gama integral. To evaluate this integral, you consider u equal to x power n. Therefore, du equal to n into x power n minus 1 into dx. And dv is e power minus x dx. dv is e power minus x dx. Therefore, v is integral e power minus x dx. That is e power minus x integration is minus e power minus x. That is v. Therefore, by integration by parts, In equal to u x power n v minus e power minus x from 0 to infinity. Limit uv minus integral v is minus e power minus x. That minus becomes plus e power minus x. v du is n into x power n minus 1 dx. So by applying upper limit for here, first term e power minus infinity. If you apply upper limit, infinity into e power minus infinity is 0. Therefore, this term becomes 0. And applying lower limit, minus x is 0, 0 power n is 0, 0 into e power minus 0, e power 0 is 1. But it is e power 0 is 1, but 0 power n is 0. Therefore, both upper and lower limit, this expression becomes 0. Because e power minus infinity value is 0. And lower limit, it's 0 power n is 0. Therefore, for both the limits, this term vanished. And you take this n outside, n into integral 0 to infinity e power minus x into x power n minus 1 dx. So, this In is now 1. After integration, this term reduces to n into In minus 1. So, In becomes n into In minus 1. This is In minus 1 because integral 0 to infinity e power minus x power n minus 1 dx is In minus 1. N minus 1 is In minus 1. Further, this integration again by integrating by parts, you will get n into n minus 1 into In minus 2. Like that, we have to proceed by step. This In minus 2 is now expanding. You will get n into n minus 1 into n minus 2 into In minus 3. Like that, this integration proceeds up to that last term n. Next term n minus 1, n minus 2, this n minus 3 into In minus 4 and n minus 4 etc. Last term n minus n minus 1. So finally it becomes 2 into 1. That's all. Final step is 1. By reducing this n minus n minus n minus etc. Finally in 2, last term is 1. This is nothing but n factorial. 1 into 2 into 3 etc. N is called, it's nothing but it is defined as n factorial. So In is n factorial. Therefore, the value of this integral is n factorial. So, integral 0 to infinity e power minus x power dx is n factorial. Similarly, In minus 1 is is in minus 1? Integral 0 to infinity. You know in minus 1 is this. E power minus infinity, 0 to infinity, e power minus x into x power n minus 1. This is in minus 1. This value is n minus 1 factorial. N minus 1 factorial. This integration specifically called Gama integral. n minus 1 is called Gama integral. That's all about this. From this expression, I conclude this, and this integral is called Gama integral. n minus 1. E power minus x into x power n minus 1. Okay? Is that? So this n minus 1 is called Gama integral. In particular, integral 0 to infinity e power minus x into x power n minus 1 dx is called, you have one dx here. This is equal to n minus 1 factorial. This is n minus 1 factorial. This integral is called Gama integral. This integral is called Gama integral, and it is denoted by symbol gamma n. This is capital Gamma notation. Integral 0 to infinity e power minus x into x power n minus 1 dx. This integral is called Gama integral, and it is denoted by gamma n. Integral 0 to infinity e power minus x into x power n minus 1 dx. This is called Gama integral. Okay? We define Gama integral like this. Gama integral is denoted by gamma n. It is integral 0 to infinity e power minus x power n minus 1 dx, whose value is n minus 1 factorial. That we derive. This integral is called Gama integral. Integral 0 to infinity e power minus x into x power n minus 1 dx, whose value is n minus 1 factorial. This integral is called Gama integral, and is denoted by gamma n equal to, and is denoted by gamma n, which is equal to integral 0 to infinity e power minus x into x power n minus 1 dx. This is called Gama integral. This gamma n is nothing but, you know the value of this integral is n minus 1 factorial. One more note I have. This gamma n plus 1. Gamma n plus 1 is, what do you get? Gamma n is n minus 1 factorial, gamma n plus 1 is n factorial. Gamma n plus 1 is, n factorial, because gamma n is n minus 1 factorial. Gamma n plus 1 is 1, less you 1, you less 1 from this n thousand, you will get n factorial. You will write, you know that n factorial is n into n minus 1 factorial. That is n into, n minus 1 factorial is gamma n. So, you have one result, that is gamma n plus 1 equal to n into gamma n. This is one result you have to remember. Gamma n plus 1 equal to n into gamma n. n into n minus 1 factorial. N minus 1 factorial is gamma n. So like that, gamma integral is we define. Next, from this, we have to reduce one result. In particular, the Gama integral is evolved for solving the following integral. That is, in this idea, in particular, you consider the integral 0 to infinity e power minus ax into x power n dx is equal to n factorial by a power n plus 1. This is one important result. Integral e power 0 to infinity e power minus ax into x power n dx is n factorial by a power n plus 1. It is derived by using this gamma integral, and it is also an important result. We are reducing this result from this expression. Integral 0 to infinity e power minus ax x power n dx is n factorial by a power n plus 1. Using this result, we are going to solve some problems in the exercise given in your textbook. Exercise 9.6, sorry, 7. In the exercise 9.7 in your textbook, evaluate, first problem, evaluate the integral 0 to infinity e power minus 3x into x power 5 dx. Here n is any positive integer. N is any positive integer. And see, this is of the form e power minus ax x power n dx is equal to, by result, n is 5. 5 factorial by a is 3. 3 power n plus 1 is 5 plus 1. N is 5, a is 3. N factorial is 5 factorial by a power 3 power 5 plus 1. N plus 1 is 5 plus 1. This is nothing but 5 factorial by 3 power 6. This is the answer for this integration. Immediately we can reduce the result from this. From this result, immediately we can reduce this problem as 5 factorial by 3 power 6. That's all about the problem given in your textbook. N is 5, A is 3. Using this result, 5 factorial by 3 power 6. Next one, second problem in your exercise, integral 0 to infinity, 0 to pi by 2. Using this idea, second problem in the exercise, evaluate the integral 0 to pi by 2, evaluate the integral 0 to pi by 2 e power minus tan inverse of x by cos power 6x dx. Integral 0 to pi by 2 e power minus tan inverse of x by cos power 6x dx. You can rewrite this problem as, you consider this integral I equal to integral 0 to pi by 2 e power minus tan inverse of x. You split this cos power 6 as cos power 4x into cos square x dx. You split this cos power 4 by cos power 6 by cos power 4 into cos square, and this is equal to integral 0 to pi by 2 e power minus tan inverse of x by cos power 4x, and this denominator cos square, if you bring it to the numerator, it becomes secant square x dx. Again, this is equal to integral 0 to pi by 2 e power minus tan inverse of x. This cos power 4, if you bring it to the numerator, it becomes secant power 4x into secant square x dx. Okay. To this problem is rewrite after using these steps. We can have derived this step. This problem can be expressed as this type after reducing these terms. Now to evaluate this, you substitute one substitution for tan x equal to t. Put t equal to tan x. So by differentiation, dt equal to secant square x dx. This secant square x dx becomes dt. And secant power 4 is 1 plus tan square x. This is equal to again integral 0 to pi by 2. This is e power minus tan x. And the secant power 4 is 1 plus secant power 4 is secant square the whole square, and that is secant power 4x you can write it as secant square x whole square into secant square x dx. And this secant square is 1 plus tan square x. So here dt equal to secant square x dx, and correspondingly we have to change the limit. What is if t equal to x equal to 0, what is t? Changing the limit x and t. If x equal to 0, t is also, if x equal to 0, tan 0 is 0, t is also 0. If x equal to pi by 2, tan 90 infinity, t equal to infinity. So the correspondingly the limits change like this. So the problem becomes that is equal to integral 0 to infinity. Secant square is 1 plus tan square the whole square. Secant square, that becomes e power minus tan inverse of x. Secant square is 1 plus tan square x the whole square into dt. Secant square dx is dt. So that is equal to integral 0 to infinity e power minus t. Tan x is t. This is 1 plus 2 tan square x plus tan power 4x into dt. So that is again equal to integral 0 to infinity e power minus t into 1 plus 2 t square, because tan x is t. 2 tan square is 2t square plus tan power 4 is t power 4 into t. So the problem now, after using this idea, the problem reduces to integral 0 to infinity e power minus t 1 plus 2t square plus t power 4 dt. Okay, now we are going to split this into three integrals. Integral 0 to infinity e power minus t into 1 e power minus t dt plus 2 into integral 0 to infinity e power minus t into t square dt plus integral 0 to infinity e power minus t into t power 4 dt. So the problem split into three integrals. Okay. Here, after integration, term by term, we have to split that integral into three integrals. That is, first I equal to integral e power minus t dt. E power minus t integration is minus e power minus t from 0 to infinity plus 2 into integral e power minus t square. It is by formula e power minus x into t power n. X power n is n factorial row. E power minus x into x power n is n factorial. This becomes 2 factorial. Plus e power minus x into x power n is n factorial. That is 4 factorial. First idea. This is e power minus x into x power n is n factorial. Therefore, e power minus infinity t square is 2 factorial, e power minus infinity t power 4 is 4 factorial. What is the idea behind this integral is, you know, integral 0 to infinity e power minus x into x power n is n factorial. Using this idea, I am evaluating these two integrals. E power minus t into t square is 2 factorial. E power minus t into t power 4 is 4 factorial. So, and applying the limits, for applying infinity, t for minus infinity, e power minus infinity 0, and applying 0, e power 0, e power minus infinity is 0, minus of minus plus, lower limit you get minus, and this minus become plus, e power 0, t is 0, e power 0 is 1, plus 2 into 2 factorial is 2, plus 4 factorial is 16, sorry 24. 1, 2, 2, 6, so 24. So 1 plus 4, 5, 5 plus 24 is 29. So answer for this problem is 29. That's all about the answer. 2 to the 4, 4 plus 24, 28 plus 1, 29. That's all about the problem. Okay? And one more problem in the textbook. I am going to solve now. Listen. Using this integral, I am evaluating these two integrals. Next, the last problem in your textbook under this topic. If integral 0 to infinity e power minus alpha x square into x cube dx is equal to 32 and alpha greater than 0, then find alpha. Then find the value of alpha. That is our problem. To solve this problem, you rewrite this problem as integral 0 to infinity e power minus, you consider this as e power minus infinity e power minus alpha x square, and I split this x cube as x square into x dx equal to 32 given. I split this x cube as x square into x, and I am going to substitute for x square, t equal to x square, dt equal to 2x dx. dt equal to 2x dx. And x dx is dt by 2. So t square is, x square is t, and x dx is dt by 2. Corresponding limits, if x equal to 0, if x equal to 0, t is also 0. If x equal to infinity, infinity square is, t is also infinity. The limits also, corresponding limits for t is 0 to infinity only. Therefore, this integral is 0 to again infinity e power minus alpha t, x square is t, x dx is dt by 2. This is equal to 32. That is 1 by 2 into integral 0 to infinity e power minus alpha t into t dt equal to 32. You know this is equal to 1 by 2. This integral value is e power ax into x power n is n factorial. 1 factorial by alpha power 1 plus 1. A power n plus 1 formula. T power n is n factorial by a power n plus 1. N is 1, so 1 factorial by alpha power 1 plus 1 equal to 32. That is 1 by 2 alpha square equal to 32. Alpha square cross multiplication, you will get 1 by 2 into 32, 1 by 64. Alpha square is 1 by 64 from this. Therefore, alpha equal to square root of 1 by 64 is 1 by 8. Therefore, alpha equal to 1 by 8. This is your answer. Our required answer is alpha square is 1 by 64. Therefore, alpha equal to 1 by 8. From this step, we can immediately say alpha equal to 1 by 8. That's all about the problem. Okay? So, Gama integral, thereby we conclude, and you follow the few more problems as examples given in your textbook. You go through the examples given in your textbook. I will stop here. We will continue the next topic in the next video. Thank you.